Good morning. Thank you for allowing me to meet with you today, specific to a project that is from Brian Tesner at Callison. I have taken the opportunity to identify through the internet some specific information about this project, even though it's a little bit light in terms of detail. So these first two screens represent images that I was able to obtain, and as you'll see, these images are quite diverse in terms of what this project entails. So Brian, what I would really like to do in the context of this meeting is to have a discussion with you. I don't really want this to be a sort of a linear presentation. I'd really like it to be back and forth, and to have an opportunity to share with you and you with us some of the details of what we can provide in terms of state-of-the-art solar control shading. So to begin that discussion, solar control shading is really the combination of best properties and integrated performance for glazing, shading, and lighting. And I don't think that those are categories of construction that are often thought of as integrated features. But we're here to say that in this modern era of new techniques and best practices, such as net zero energy buildings and living building challenge projects and LEED 4, that there's an ongoing need and desire to have more efficient buildings. And what we're hopeful of doing today is to give you information about the state of the art as it relates to solar control shading and its role in the integration of these features, which we would refer to as the entire fenestration model, having an effect on curtain walls, windows, skylights, clear stories, and the thermal properties, the lighting control properties of the entire building envelope. So our most popular project, and I'm going to cover several different categories of combined LouverShade halcyon shading, so that we can maybe drill down into some areas that are specific to your project. Because as I mentioned at the beginning, I don't have the construction documents nor enough detail to understand what you may be thinking in terms of shading integration. So I'm going to touch on several different categories that I think are very important to the best efficiency of your project, and most importantly to the presentation of that building to its clients and tenants and developer and owner. So the dual zone shading system has been in existence for a few years. We have some very significant projects. I'm going to show you one of them here in just a second. But I think most importantly, there's a verified efficiency of the way in which this system works. And that verification was paid for by the Department of Energy, the U.S. Department of Energy. And the research was conducted by Lawrence Berkeley National Labs in Berkeley, California. And the findings that they came up with was that compared to a baseline of standard roller shades, this dual zone shading system is between 21 and 51% more efficient in terms of lighting savings than a baseline of roller shades. And that that 21 to 51% debate is based upon window to wall ratios, etc. So obviously fewer windows, less effect, more windows, more effect. But and then as you see the second bullet, that indicates that the system also has an efficiency in terms of the thermal envelope of the building, saving up to 15% in HVAC, both cooling for summer, heating for winter, over this baseline standard roller shade model. This product is also fully certified by the Living Building Challenge under their Declare program. So for red list materials, Declare is specific to certifying that there are no red list components in any of the portions of this product, whether that be the shading material, the brackets, the motors, the control system. It's all red list free. And then lastly, the bullet that identifies LEED 4 contribution, we believe that we can contribute up to 19 LEED points by installing this system in your projects. And I'll break that down for you here in just a minute. Dual zone shading has a price performance metric that reduces lighting costs and provides light harvesting efficiencies, 100% glare removal, and this glare removal is based upon any solar conditions, so you will always have a maximum amount of natural light and always remove glare from the system. In addition to that, the research I was referring to at Lawrence Berkeley National Labs they conducted a survey. We did two different projects there. One was a lab configuration for Lawrence Berkeley, and a second was a full building installation model there at the Dellums Federal Building in Oakland, California. And they did a survey at the end where the respondents indicated to the tune of 80% of acceptance and preference of the dual zone system over what they had been dealing with, which was a vinyl vertical blind type of a configuration. So not only is it efficient, but people like it. So this illustration shows you kind of the most effective solar condition for natural light. But as you can see, when we have that most effective solar condition, we also have glare. And so what do? Our typical scenario is that we lower the shades, we remove the natural light from the building because glare is obviously a very annoying and disruptive condition to live with. So as you can see, the lights that are shown here are on full, the shades are down, the sun is shining, we have no natural light present in the space. But the dual zone system changes all of that by dividing the glazing surface into two zones. The upper portion you see here we call the daylight glazing or light harvesting zone, wherein louvers are inverted. These are 2-inch, think of these as Venetian blinds flipped upside down. They are very, very effective, very inexpensive, and as you can see, they direct natural light inward and upward, and they also make it possible for the daylight zones. As you can see, the lights in the zone closest to the windows is now off, so now we're saving electricity because we don't need the lights to be on in this solar condition where glare exists, because we're making best use of it and using the natural light to light the space. And the second, the lower section, which we call the view glazing or glare zone, the shades are lowered, and because of the effectiveness of halcyon, I'm going to show you in just a second, they are very effective in blocking glare and retaining view for those folks in the office space who enjoy that view. So I talked a little bit about light harvesting. So daylighting principles for construction, and here's an outtake. I'm going to just step outside here for just a moment. It's very important that in each jurisdiction, in particular for this project in Chicago, Illinois, that we understand what the building codes are as it relates to daylight zones. Most building codes in the US require a primary and secondary daylight zone. And sometimes, and each of those are governed and regulated by light sensors on the ceiling that detect natural light. If it's a stepped lighting configuration, then certain portions of a fixture shut down when natural light is present. That's a horrible situation for an office. Most jurisdictions in the US now have mandated that in critical visual task applications, such as an office, such as this project, that continuous dimming is the rule. So it's important that you dig into the local building codes and understand that to be the case, because that would be a critical piece of information to deliver at this juncture in our presentation. So let's assume that this is a scenario where we have continuous dimming as our daylighting strategy in Chicago, Illinois. And so based upon that, I'm going to continue. So the example you see here is daylight harvesting. And this is a principle by which the natural light, as we just discussed, is directed inward and outward into the space, into the building space. And then by virtue of the primary and secondary daylight zones that are mandated by local building codes, the primary daylight zone here, the light is off because we have sufficient natural light to provide the prescribed critical visual task lighting for the space. And then the secondary zone, the secondary daylight zone, is at some midpoint because we are still getting a good effect for natural light, but obviously not to the extent that it is at the closest to the window. And then the further in, outside of the primary and secondary daylight zones, then we have really no effect of natural light, and in those areas, electrical light is being used. But the thing that's important to remember here is that if this was a configuration without a dual zone shading system, we would have 100% electrical light being utilized because the shades would be down. In this example, because we have no glare entering the space and we're able to use the natural light for lighting and reducing costs for lighting, then those primary and secondary daylight zones can do what they were designed to do, which is to save cost for electrical energy. So this is another view of this dual zone system. You see the upper daylight glazing, light harvesting zone, and the lower view glazing or glare zone. Typically, the split point between these 2 points, the glare zone and the light harvesting zone, are about 7 feet from the floor. Nothing magical there, but what we're trying to do is to provide a break point so that the tilt of the louvers will prevent glare from entering the space at its farthest extremity. So if I have a 100-foot open office area, my break point between these two, view glazing and daylight glazing, will be slightly higher than if I have enclosed cubicles, etc. So that's all part of lighting design, and that's one of the services that we provide at Halcyon, is to help you engineer the proper spacing for the breakpoints for these two types of, for these two components of a dual zone system. This is another view of those 2-inch inverted louvers that we were just talking about. We cut some slits in cloth and protruded the louvers through and directed light at them. And you see the two things that are happening here. There's the projection of natural light inward and upward, and there is a down shadow angle that prevents glare from entering the space. So this is the magic of this system for dual zone at the upper portion that makes maximum use of natural light in its ability to prevent glare and also maximize natural light in a very low cost and effective way. Halcyon, and here's another outtake. I'm not going to take a tremendous amount of time here because obviously Halcyon folks who are going to be on site will hammer this dramatically. But I will say, now we're back into character here for the presentation to Brian Tesner at Callison. What I would like to say is that Halcyon has thermal properties and view retention properties that are without peer. This product was selected for the dual zone application and was verified as being the most effective type of shading strategy for a dual zone system, as verified by the research done at Lawrence Berkeley National Labs. So the best way to illustrate this is to show you an example project. The project I'll show you is a new Google campus in Kirkland, Washington. And what you see here is an interior view looking out of a typical dual zone system. And you see the upper louvers doing their work, and then you see the lower view glazing. The shades are down. Most people don't believe me when I tell them that, but this is an illustration of how effectively Halcyon is able to block glare and retain view through the view glazing. If this was a standard fabric roller shade, it would be very grainy at best, and certainly wouldn't be a pleasant view. This is almost as good as looking out an open window, but in this case without the glare that would normally be present if that window had no shading in it. This particular system in Kirkland is a fully automated system. We do standard manual systems, both in terms of the upper view glazing, the upper daylight glazing and the lower view glazing. However, if we're going to make maximum use of natural light, automating the upper daylight glazing louvers will make them the most efficient. So assuming we do that, then of course in the lower view glazing, the Halcyon lower roller shade view glazing, we recommend most of the time that remain a manual system, because folks that live and work in a space always want to have control over their shades. And so if those lower view glazing roller shades are motorized, then you're going to have to provide alternate control for the workers in that area, which adds cost and complexity. So automate and motorize the upper daylight glazing louvers, leave the lower view glazing roller shade manual, and you have, in our view, an ideal system. So this automation portion that I'm referring to right now only applies to the upper inverted louvers. So there is a notion of determining what we call an on-sun event. When I have high intensity of light, then the louvers must be in their proper position and angle. If I have a low sun event, then frankly, I can raise the shades. If I have clouds and rain, the most effective way to bring natural light into the space is to remove the shades entirely, to lift them so that there's no louver in front of them. So when I have what we call an on-sun event or an off-sun event, on-sun means that I have sun in the space, and I have to lower the louvers and rotate them. If I have an off-sun event, such as a cloudy, rainy day, then the shades lift. For an off-sun event, that's totally programmable. In the case of what we did at Google in Kirkland, we actually made the off-sun event happen with a 3-hour delay. So if you have a situation which in the springtime in the Seattle area, you can have clouds and sun, frequently going, clouds over the sun, disappearing, sun out, and so on. And so that would create this scenario where the shades are going up and down all the time. So if we have a system where an off-sun event is delayed by, let's say, as much as 3 hours, then those louvers will remain until the 3-hour window passes, and then the shades will lift. That's a very good system for not having this distractive up and down motion of shades. So that's what we did at Google. It's totally programmable. The louvers themselves will rotate at a specific sun angle, and that is based upon the orientation of the building. So this particular example I'm showing you here would be in January, and we know that the sun angles in January are different than they are in July, so my louvers will be in different positions in January as they would be in July, and they will also be at different positions throughout the day. If it's 9:45 a.m., they'll rotate to 72 degrees, and as you can see at 9:45, then they'll adjust again, and then after 10:30, they'll adjust again. This is all based upon a schedule that is specific to the region and is also specific to the orientation of the building. So if I'm facing southeast, then I'll have a specific schedule. If I'm facing west, I'll have a different schedule. Manual overrides are available in all situations. There's in the manual override instance, the presets would move to a maximum glare control position, so that in this case I've overridden the system, so I have to obviously make certain that I don't have glare entering the space. If another preset override wants to close the louvers entirely, then obviously that's what'll happen. Timers are based on a specific time of day, always programmed into the system. And then, of course, there are roof-mounted sun sensors that provide real-time information that determines the on-sun and off-sun conditions. And the louvers will move, as it states here, up to 180 different positions throughout the year based upon all the conditions that I've just described. So this is a very effective system, and it automates the daylight glazing louvers to the extent that they are the most effective possible. I'm not certain if there are any exterior shading considerations for your building there in Chicago. If there are skylights, we do both interior and exterior rack arm systems, and these are almost always automated as well. We also do retractable horizontal exterior louvers, as the left illustration shows here. So if there are exterior plans for this project in Chicago, we can certainly help with that. The reason that this is important is in this world of maximum efficiency, exterior shading captures solar conditions to a much more effective degree than interior, to the extent that exterior rack arms and exterior retractable horizontal louvers are some 93% effective in blocking solar energy before it hits the glazing. So it's very popular in Europe, Australia, China, not so much in the US, although we are seeing an uptick by virtue of the many Living Building Challenge and other types of maximum efficiency projects going on. So if that's something of interest, we have the best in the business as it relates to exterior products, and I'd love to talk to you about those. One of the projects we did with our exterior retractable horizontal louvers was at the Kern Center in Hampshire College in Amherst, Massachusetts. This was a Living Building Challenge project where they're trying to meet the objective of a net zero energy building. Obviously, it required the efficiencies of exterior as well as declare. All of our products, including the exteriors, have declare labels, which means that there are no red list materials in any of them. I've already talked about the research that was done for the Green Proving Ground and the Department of Energy's high impact technology research at Lawrence Berkeley, so I won't cover that again. And of course, LEED 4, I'm going to give you an example here in just a second. One of the things I think that's important for you to understand is that all of our products, as I mentioned, are Declare specific. And this is what you'll find if you go to the Declare database on the International Living Future Institute's project site. All of our systems, the dual zone control shading system, this is the first page of the Declare database. All of our exterior retractable horizontal louvers, this is the first page of what you'll see when you go to the Declare database, as well as our rack arm systems. So all products are certified under Declare. They are certified to be Living Building Challenge specific, and also are very effective for LEED 4, in addition to some other standards that are emerging and being accepted universally. The HPD, the Health Product Declaration Open Standard, is one that takes many of the rules and regulations from the state of California that relate specifically to VOCs, volatile organic compound, and other types of limits for off-gassing that are controlled. All of our products comply. The Halcyon shade complies totally because it does not require any type of halogenated fire retardants to meet the VOC standards. So very important additional piece of standards compliance that we work with. RoHS, if you're familiar with RoHS, this is a standard for removing all lead from circuit boards. So for automation and control systems, all of our products, all of our controls are RoHS specific. So we meet all those specifications. We talked at the beginning about the specifics of our work with Lawrence Berkeley National Labs and the integration of glazing, shading, and lighting as an integrated product. There are certainly other factors as well in terms of specifics for human interaction with systems, the ability to have view when they're, in many instances with standard roller shades, you wouldn't. Reduced electrical consumption, load mitigation, and all those things that we've been talking about are part of what we would like to help you design into this project there in Chicago. We also have a white paper specific to LEED 4. I'm not going to spend a lot of time on this because if you would like to read about our objectives and integration with LEED 4, I'd be delighted to do that. But what I will do is to show you the chart that we believe will earn us 19 LEED points. So there's one important reference point here. You see the little green credit for declared compliance specific to no red list materials. This is now part of LEED 4. So automatically, when you have a Halcyon LouverShade product, you're going to earn 2 LEED points by virtue of declared compliance. And of course, all of these other categories, I won't spend a great deal of time talking about them here, but I think we have a very strong case to make for earning these additional LEED 4 points if your project is attempting to reach LEED 4 status, so platinum status. So I'd love to talk to you about that. All of our folks there on site would like to drill down into LEED if that is part of the goal of this particular project. It's also important that we highlight what we call a hybrid product, where a portion of the system is exterior, a portion of it is interior. So for example, the Halcyon roller shade could be interior and the louvers could be exterior. The light harvesting louvers can be exterior, either fully with a full drop to the glazing or a partial drop to the glazing, just simply providing light harvesting. We've done a number of these systems. This happens to be one in a large, it's a museum where there's a tremendous amount of effort made to protect artifacts and against the effects of light, of damaging light. So what you see here are exterior louvers. Here are those louvers closed. These are a custom configured 10-inch aluminum type of louver. And you notice that the lower section of the system is an interior roller shade. So this is the epitome, an example of the hybrid system that I've been referring to, with exterior louvers, interior roller shades. We also do other types of custom applications. If there's a need for a vertical blind, this happens to be vertical exterior louvers that are hurricane rated. We do this kind of work. We do custom configuration and design wherever that might be needed. And of course, as I mentioned earlier, there are human factors in addition to efficiencies and thermal envelope efficiencies and light savings, light harvesting savings, such as the circadian rhythms type of value that natural light provides. Numerous studies point to the value of natural light with better test scores for students in schools, higher sales per square foot in retail, and more rapid recovery in hospitals. So there are other reasons in addition to what we've discussed in terms of the value of natural light in making it available effectively. One last subject I'll point to here, I talked about custom applications. This happens to be a project that we did in New York City for JP Morgan Chase. I'm pretty sure this was the result of a 3-martini lunch from the board, but what they wanted was to create a custom interior louvered shading system with this design that you see that has absolutely no redeeming values in terms of effectiveness, but it did have an aesthetic value that was deemed important by the board of directors of JP Morgan Chase. So we designed it, built it, installed it, and here you see the result. And so the only reason I point this out to you is another example, a case in point of our willingness to work with you if you have some areas of customization that you're considering. We'll help you design and take those designs all the way through completion. So as a conclusion, we know that the built environment for all of the U.S. And namely what some of the 2030 mandates that are in every state, all led by the state of California. California is sort of the leading edge for all things sustainability in our futures. But we know that building codes are continually migrating toward greater efficiency. Continuous dimming lighting controls are now a mandate specific to light harvesting and primary and secondary daylight zones. Glazing efficiencies are becoming specifically greater over time. Shading plays an enormously important role, and we're here to help you make the best use of shading strategies because that's the business we're in. Pricing reference, give you a sense of some of the reference pricing tables. Electrochromic sage glass type applications are, a number of them have found their way into high efficiency buildings. They're enormously expensive. The cost you see here, and they always have to have some kind of an auxiliary shading system, let's say a standard roller shade. So the electrochromic glass at $75 per square foot would add at least another $20 to $25 per glazing square foot to add electrical components, because obviously every window has to be wired for electrochromic. Very expensive. Electrochromic alone, again, still going to be close to $100 per glazing square foot. If we look at option number 3 with a roller shade and retractable horizontal louvers, and then let's add in the cost of low E dual pane glazing, about $59 per glazing square foot. And then we start looking at some of the options we've talked about here today, such as the Google model, the upper motorized and automated daylight glazing louvers and halcyon lower roller shade, inclusive of the dual pane low E glass at about $40 per glazing square foot, and a manual system, again with standard dual zone shade with manual upper louvers and manual lower halcyon roller shades at about $12 per glazing square foot, and inclusive of dual pane low E at combined $27 per glazing square foot. So I think I'm hopeful that the illustration and the examples and detail we provided today would indicate the reason in which and for which that we should be working with you to provide the solar control shading solutions.